Hello. Wizardus here. Today, finally, something red teamy. Please excuse me for uploading this a bit later. I had some work to do. Alright, time to solve day 5 of Adult Cyber. If you don't want this, refer to my first video where I explain it, or first link in the description. You're gonna have everything written, and if you wanna join us, use the second link. So then, let's take part in this beautiful story. Alright, this topic, XXE. Finally something red teamy. These days in Wareville flew by, and software's projects were nearly complete just in time for Christmas. One evening, after wrapping up work, Software was strolling through the town when he came across a young boy looking dejected. Curious, Software asked, "What would you like for Christmas?" The boy replied with a sigh. "I wish for a teddy bear, but I know that my family can't afford one." That's sad. This brief conversation sparked an idea in Software's mind. What if there was a platform where everyone in town could share their Christmas wishes and the mayor's office could help make them come true? Excited by the potential, Software introduced the idea to Mayor Malware, who embraced it immediately. The mayor encouraged the team to build the platform for people of Wareville. Through developers' dedication and effort, the platform was soon ready and became an instant hit. Townspeople loved it. However, in the rush to meet the holiday deadline, the team had overlooked something critical: for security testing. Even Mayor Malware had chipped in to help develop a feature in the final hours. Now it's up to you to ensure the application is secure and free of vulnerabilities. Can you guarantee a platform runs safely for the people of Wareville? So pretty much we're talking about XML External Entity and what XML even is. So let me start with this one. XML is a commonly used method to transport and store data in a structured format that humans and machines can easily understand. Consider a scenario where two computers need to communicate and share data. Both devices need to agree on a common format for exchanging information. This agreement is known as XML. You can think of it as a digital filing cabinet. Just as a filing cabinet has folders with labeled documents inside, XML uses tags to label and organize information. These tags are like folders that define the type of data stored. This is what XML looks like: a simple piece of text information organized in a structured manner: name, address, email, phone. Alright, in this case, tags people, name, address, etc. are like folders in a filing cabinet, but now they store data about glitch. Content inside tags like glitch, Wareville 1234567 presents the actual data being stored. Like before, the key benefit of XML is that it is easily shareable and customizable, allowing you to create your own tags. Now what is DTD? Now that the two computers have agreed to share data in common format, what about the structure of the format? Here is where the DTD comes into play. A DTD is a set of rules that define the structure of an XML document. Just like a database scheme, it acts like a blueprint telling you what elements, tags, and attributes are allowed in an XML file. Think of it as a guideline that ensures the XML document follows a specific structure. For example, if you want to ensure an XML document about people will always include a name, address, email, and phone number, we should define those rules through DTD as shown below. Element people, name, address, name, PC data. Alright. In the above DTD, exclamation mark element defines the elements that are allowed, like name, address, email, and phone, whereas hash PC data stands for parsed people data, meaning it will consist of just plain text. Alright, so far both computers have agreed on the format, the structure of data, and the type of data that they will share. Entities in XML are placeholders that allow insertion of large chunks of data or referencing internal or external files. They assist in making the XML file easy to manage, especially when the same data is repeated multiple times. Entities can be defined internally within the XML document or externally referencing data from an outside source. For example, an external entity references data from an external file or resource. In the following code, the entity @x could refer to an external file located at HTTP TryHackMe robots, which would be loaded into XML if allowed by the system. Alright, so it's we are specifically using discussing external entities because it is one of the main reasons that XXE is introduced if not properly managed. After understanding XML and how entities work, we can now explore XXE vulnerability. XXE is an attack that takes advantage of how XML parsers should handle external entities. When a web application processes an XML file that contains an external entity, the parser attempts to load or execute whatever resource the entry points to. If necessary, sanitization is not in place. The attacker may point the entity to any malicious source code, causing the undesired behavior of the web app. For example, if a vulnerable XML parser processes this external definition, here the entirety at THM file refers to sensitive file, etc. password on the system. When the XML is processed, the parser will try to load and display the contents of the file, exposing sensitive information to the attacker. In the upcoming tasks, we will examine how XXE works and how to exploit it. Before moving forward, review the questions in the connection card shown below. Alright, we need to start the VM and we need to start the attack box. Let's start the VM first, then we can launch our terminal and connect to the VPN. I'm going to also head to my folders, so it's CD5, yeah, it's CD5, TryHackMe AOC, CD5. I had nothing in there, yes, clear. Let's now jump back and grab a machine IP. It's going to be there in 20 seconds. Now that you understand the basics, concepts related to XML and XXE, we will analyze an application that allows users to view and add products to carts and perform the checkout activity. You can access the WhereView application hosted on Machine. This application allows users to request their Christmas wishes. As a pen tester, it's important to first analyze the flow of the application. First, the user will browse through the product and see and add items of interest to their wishlist at product.php. Click on Add to Wishlist under WellView's Jolly Cap as shown below. After adding products to the wishlist, the cart button will visit cart to see product item to cart. On the cart page, click Proceed to Checkout. On the checkout page, the user will be prompted to enter his name and address as shown below. Enter a name, choice and address, and then click Complete Checkout. Place the wish. Once you complete the wish, you'll be shown message Wish successful. Your wish has been saved as Wish 21 as shown below. Wish 21 indicates that the wish is placed by a user on the website. Once you click on Wish 21, you will see Forbidden Page because the details are inaccessible to admins, who can try to bypass it and access other people's wishes. This is what we will try to perform in this task. Alright, we have IP. I'm gonna copy it and export it. Export IP, then export IP here. And we can now visit the page. WhereView Jolly Cap. Alright, it's all here as it was. Before discussing exploiting XXE on the web, let's learn how to intercept the request. First, we need to configure the environment so that as a pen tester, all web traffic comes from our browser is routed through burp suite. This allows us to see and manipulate the requests we browse. There is a burp suite configuration. I will not be reading that, but as usual, it's in the description so you can just check it out yourself. Let's start burp. Can be seen under proxy. You actually just have here a Foxy proxy pointing to localhost port 8080, which also points. So my burp points to. And yeah, what is happening in the backend? Now when you visit the URL http://product.php and click Add to Wishlist, an Ajax call is made to wishlist.php with the following XML as an input. In the above, XML product ID tag contains the ID of the product, which is 1 in this case. Now let's review Add to Wishlist request logged in burp suite's HTTP history. option under the proxy tab. So we need to first visit the product.php, click add to wishlist. All right. Let the burp suit start. We can learn the proxy, intercept this on, and click maybe on product. Forward, yes, we forward the request. And I can click add to wishlist. Since I post, yes, exactly. I'm gonna save it in the repeater because I'll use Ctrl R. It's logged as burp history. Yes, exactly. The wishlist PHP accepts the request and parses the request using the following code. Nice. So it's a white box. Fantastic. Single entity loader false. When the user sends specific crafted XML data to the application on the line, libxml disable entry loader false allows XML parser to load external entities. This means the XML input can include external file references or requests to remote servers. When the XML is processed by simple XML load string with the libxml no end option, the app resolves external entities, allowing attackers to access to sensitive files or allowing them to make unintended requests from the server. So XX is something also like CSRF, if I recall correctly. Yeah, like what if we update the XML request to include references for external entities? We'll use the following XML instead of above XML. Let's copy this. And we had it in the repeater. And let's go there and use it. Paste it here. It's the yeah, and let's send. As you see, it returned us the etc/hosts. When we send this data to external payload, the first two lines use the external entity called payload. The end line entity payload system tells the XML parser to replace the payload reference with the contents of the file etc. hosts on the server. When the XML is processed, instead of a normal product ID, the application will try to load and include the contents of the file specified in the entry etc. hosts. Now let's perform the exploitation by repeating the process we captured earlier. The burp suite has feature node repeater that allows us to send multiple requests. Right-click on wishlist, post request, and send data. That's exactly what I had done before. Send the post data there. And we update the XML payload with the new data shown below and send the modified request. That's exactly what we have done as well. When we clicked send, the server processed the malicious XML payload, which included the external entity reference to etc. hosts. As a result, the wishlist PHP responded with the contents of etc. hosts file, leading to an XXE vulnerability. Now that you have identified the vulnerability in the application, it's time to see it in action. MaxKitty software has tasked us with finding loopholes. We've successfully uncovered one in the wishlist.php endpoint, but our warning doesn't end there. Let's take it a step further and assess the potential impact this vulnerability could have on the application. Earlier, we discovered a page accessible only by administrators, which seems like an exciting target. What if we could use the vulnerability we've found to access sensitive information, like the wishes placed by the townspeople? Now that our objective is clear, let's leverage the vulnerability we discovered to read the contents of each wishes page and demonstrate the full extent of this flaw to help MaxKitty secure the platform. To get started, let's recall the page that is only accessible by admins /wishes/wish.txt. Using this path, we just need to guess the potential absolute path of the file. Typically, web applications are hosted on var www.html. This is true, yet only for PHP websites, so Apache and Nginx. If you see this running, it's mostly var www.html, or it can be just var www and some subdomain. With that in mind, let's build our new payload to read the wishes while leveraging the vulnerability. We can just use payload system and then copy just this part because the rest is there. System, let's send it. Exactly. Name your malware, address test, product, wire decay, quantity 1. To Surprisingly, we got lucky that our assumption worked. The next thing to do is to see whether we can view more wishes in our discovery. To do this, let's try replacing wish1.txt with wish2. As a result, we were able to view the next wish. You may observe we just increment number by 1. Given this, you may continue checking the orders, the wishes, and see all the wishes stored in the application. After iterating through the wishes, we have provided the potential impact of the vulnerability, and anyone who leverages this could read the wishes submitted by townspeople of Wareville. Alright, it was confirmed that the application was vulnerable, and developers were not at fault since they only wanted to give the townspeople something before Christmas. However, it became evident that bypassing security testing led an application that did not securely handle paying requests. As soon as the vulnerability was discovered, Maxkedi promptly coordinated with their developers to implement the necessary mitigations. The following proactive approach helped to address the potential risk against XXE. First, disable external entity loading. You can prevent XXE by settling libxml disable until loaded true. Validate incentivize user input. Ensure that only expected is processed, reducing the risk of malicious content being included in the request. For example, remove stuff like codes or passwords from the request. After discovering the vulnerability, Maxkedi immediately remembered that the changelog file exists within the web application stored at the following endpoint. After checking it, it can be seen that someone pushed the vulnerable code within the application after software Steam. With discovery, Maxkedi still couldn't confirm whether the mayor intentionally made the application vulnerable. However, the mayor had already become suspicious and Maxkedi began to formulate theories about his possible involvement. Alright, that's it about theory. Let's jump to practice. If you'd like to learn more about XXE or any other vulnerability, Porter's Rigorous Lab, which I'm gonna link in the description as well, is a great resource. Today, because we're talking about XML External Entity, we're gonna link their whole page about this vulnerability, but all the other things are explained there as well with really cool labs. I personally, remember, took IDOR class and SQL injection, and they all really help with understanding how the web works. Alright, enough for the promo. What's the flag like for the wishes? Let's try maybe wish number 3. Or maybe wish number 0. Try to parse XML, alright, wish number 4. It's invalid. Number 5. The wishes. Still the same thing, wish number 6. Good, as always, the same thing, wish number 7. Wish number 8. Wish number 9. Number 10. Let's try to set our own wish, so then we can see which. Oh yeah, I forgot to turn on the proxy. Oh, fix the wishlist page. That's the flag. My malware backdoors. I guess that's the flag in the possible proof sabotage. Oh yeah, and the TryHackMe also has XXE room. I'm gonna check for you if it's free or not. Mark is complete and complete as well. Yep, it's a free room, so it's definitely no, it's not a free room. That's sad. Add to wish list. On your wish list. Dang it, so let's go to home and just refresh the page. I guess let's just maybe view this study of the Ville, add it to wish list. Successfully, yeah. Go to cart. And maybe I can remove the teddy and just proceed to checkout. Gonna put whatever here and whatever here. Complete checkout. as wish 21. All right, so I guess let's start maybe from the back and go with wish 20. '21 is ours. Wish 19. Wish 18. Wish 17. Wish 16. Wish 15. Yep, the flag is THM brute force saying my way. Yeah. By the way, I now got a idea. You can do it like me, or you can also use. You can just click on here, click send to the intruder. There is an attack. By submitting here checkout, we see that our wish is 21, so it will be up until 21. We can replace this here 15 with click here add an ad, and to place here number. You choose a sniper because these are single to the payloads. As payloads, we can just add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Or I can just choose, for example, here numbers. Then you do it from 0 to 20, step 1. And now we can run start the attack. Yes, I know it contains a demo. You now see the length. And when it reaches number 14, number 15, it's a bit bigger. In our repeater, we see that now wish 15 has the flag. And that's how you can use Brute Intruder to perform simple brute force. Alright, that's it for today. Thanks a lot for watching, I hope you enjoyed it. If you really liked what I'm doing here, subscribe, leave a like, it really motivates me to create more stuff for you. You can expect, in some while, a next video from day 6. And yeah, that's really about it. See you next time.